A very good morning to all of you. Students, today we are going to begin with the chapter Presentation of Data, class 11th. And today we are going to discuss about graphical presentation of data. The topics which we are going to cover today are histograms, polygon, ogives, time series, graph. Let us have a look. Histograms. What are histograms? Students, you all have done bar diagrams in your previous year classes. Histograms are nothing different to bar diagrams. A histogram is an area diagram. It can be defined as a set of rectangles with bases along with the intervals between class boundaries and with areas proportional to frequencies in the corresponding classes. In such representations, all the rectangles are adjacent since the base covers the intervals between class boundaries. The heights of rectangles are proportional to corresponding frequencies of similar classes, and for different classes, the heights will be proportional to corresponding frequency densities. Let's have a look over the how to make histograms also. Let me first show you how we are going to create it. You need to follow the below steps to construct a histogram. Let us begin by marking the class intervals on x-axis and frequency on y-axis, which we have done in the similar way while we were preparing bar diagram. Then the scales for both the axes have to be same. For example, if you are taking 1, 2, 3, 4, so the scales for both the axes, they need to be same. Class intervals needs to be exclusive. Draw rectangles with bases as class intervals and corresponding frequencies as heights, that is as y-axis, on y-axis. A rectangle is built on each class interval. Since the class limits are marked on the horizontal axis and the frequencies are indicated on the vertical axis. The height of each rectangle is proportional to the corresponding class frequency if the class intervals are equal. The area of every individual rectangle is proportional to the corresponding class frequency if the intervals are unequal. Although histograms seem similar to graphs, there is slight difference between them. The histogram does not involve any gaps between the two successive bars. Let's have a look over the practical illustration. See, as you can see, histograms with equal class intervals. What we have done, for a histogram with equal class intervals, the class width is constant, that is 0 to 20, 20 to 40. We all can see over here, the class width is 20. As you all can see, x-axis show percentage score, that is this score with equal class intervals, and the density, that is frequency, is plotted on the y-axis. We are going to plot it like this: 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. From 0 to 20, we are having a range of 0.2. So we are going to plot it 0.2 range over here and draw a rectangle beginning from 0 to 20 till 0.2 point, and which will represent an area of that rectangle. That is the first percentage score. Next it comes 0.9. From 20 to 40 is 0.9 is, so 20, 0.9, we are going to mark it down. In the similar way, 40, 0.9, draw a rectangle by stretching a line, and in the similar way 20 to 40 area has been created. In the similar way, 40 to 60, it represents 4.3. So 4 is over here, 4.5 is over here, 4.3 represents in the midway. So 40, 4.3 point has been marked over here. 60, 4.3 point has been marked over here. And we're going to join this line, and in this way we are going to get one more area of rectangle representing 40 to 60 as 4.3 as its frequency. Now, as we discussed, histogram does not represent any difference. That is, there is no space between this. However, bar diagram has a space. So histograms, in a way, it is just one slight difference from the bar diagram. That is, there will not be any space between the rectangles. Moving on to next. Next, we are going to discuss about time series graphs. The table shows the number of visitors per quarter, that is per 3 months, to a seaside town. As you can see, quarter, students, it will always be having a time related something. 2005, 2005, 2005, 2006. So an area is being presented or a time is being presented, whereas it could not be seen in the previous questions. So if the data is plotted into a graph, this will be a time series graph. How we're going to plot it down? 14. For the first quarter, we are having 14. Second quarter, we are having 24. Third quarter, we are having 9. Fourth quarter, we are having 8. In the similar way, when we are going to join them from this to this to this, students, we are not creating, we are not adjoining these lines from the axis. We are only joining the points which have been plotted. So in this way, we get a time series graph. All right, moving ahead. From the graph, it can be seen that there is a large fluctuation each year in the amount of visitors. However, there is a pattern that repeats each year. For example, many more people visit in the summer months than they do in the winter ones, and this is in the same year by year. Another example of time series graph is also represented by the same. This is also an example of the time series graph where we are taking a time period as its x-axis base. Next, frequency polygons. A frequency polygon is almost identical to a histogram, which is used to compare sets of data or to display a cumulative frequency distribution. It uses a line graph to represent quantitative data. Statistics deals with the collection of data and information for a particular purpose. The tabulation of each run for each ball in cricket gives the statistics of the game. Tables, graphs, pie charts, bar graphs, histograms, polygons, etc. are used to represent statistical data pictorially. Frequency polygons are a visually substantial method of representing quantitative data and its frequency. Let us discuss how to represent a frequency polygon. See over here. In a batch of 400 students, the height of students is given in the following table. 140 to 150, 74. 150 to 160, 163. 160 to 170, 135. Now we are going to create a histogram as we created in the previous topic. Now rectangular bars of its class equal to class size and the length of the bars corresponding to frequency of the class interval is drawn. Following steps are to be followed to construct a histogram for the given data. Now the heights are represented on the horizontal axis on a suitable scale as shown. The number of students is represented on the vertical axis as suitable. So students, this ends up our frequency polygon. How we are going to plot it? Let's have a look. ABCD represents the given data graphically in form of frequency polygon as. Students, when we are going to draw a histogram and at the mid of the histogram point, when you're going to plot a point as B at each rectangle, point C, midpoint of each rectangle, point D, midpoint of this rectangle, point E of midpoint of this rectangle. In the similar way, one point from the beginning of x-axis, one point from the beginning of x-axis at the end. And when we're going to join these all points, we get a frequency polygon. The difference between time series graph and frequency polygon is basically that time series graph does not touch the axis, whereas your frequency polygon touches both the axis, however, both of the x-axis only. So this is for today. Have a good day. All the very best. Kindly go through whatever has been taught. Have a good day. Stay safe. Stay home.